Okay, I hope you had a good weekend. We're kind of wrapping up here. This will be last week kind of assignments. Next week will be our last unit, kind of going through the test there. But I had you watch a couple videos on fractions, and I always enjoy Mathanix. I like some of the things they share. So I think Khan Academy was another one I put on there. But anyway, I kind of wanted to do a little video as far as explain some of those same things in just more of a classroom, of our classroom kind of setting, and talk about fractions a little bit. And I usually, when I'm at the school, I have these pool noodles that I use to kind of break down. But I've grabbed a couple examples here of a baking thing, because that's something to deal with fractions, also money. And so I'm going to use that a little bit to kind of describe what a fraction is. But people hear that term fractions, they freak out, and like, oh, I hate fractions. And I always try to explain they're not clowns. They're not truly scary. I just, it's one of those things where I think sometimes it's the rules of fractions that trip people up and they get, upset. But we actually use fractions every day, more than you even think about. That once you break it down and start really kind of getting used to those rules and understanding why you use them, hopefully it will help you remember how to work with fractions. As far as what a fraction is, one fraction that we use all the time that we don't even really think about being a fraction is a half. We all kind of understand halves of something. If I have a candy bar, and now I wish I do because I'm hungry, if I broke that candy bar in half, everybody understands that. You get half of it, you get half of it, or maybe I just broke it in half to eat both halves of it. But that is, that's one that people don't even really think about, but it is a fraction. And I always say a fraction is just a division problem. It's just written different. In fact, if I wrote this out, let's say I put the 1 and then this symbol here, I'm going to turn it into the division symbol and then put this here. So it's like I'm reading top to bottom. 1 divided by 2. That's all that a fraction is. In fact, the fraction symbol is, the division symbol here is a fraction. Okay, it's like putting a blank space here, putting something here, putting something here. And so if you read it like that, 1 divided by 2, that's all that a fraction is. And if you hit in your calculator 1 divided by 2, it's going to come out as 0.50. Those are the same, or even 0.5. Most calculators won't put the 0 there. But that is showing you these are all the same values. Okay, 0.5, if we think in terms of money, 50 cents is the same as half a dollar. I put that, I got the 2 quarters. 50 cents is the same as a dollar, or is the same as half a dollar. So that half has a value of 0.5. It really is, fraction is just a way to express, these symbols. It's not a different value than this. These are the exact same value. It's just one's expressed as a decimal, one's expressed as a fraction. We did a problem on the test. I'm not going to do the whole problem because I think I have a couple that still need to finish that, but it was 5 into 4,892, and you divided it out, and that's the part I'm not going to do. You divided it out, and at the very end, you had a remainder of 2, and we showed where we put that over 5. This was one that we did as a fraction remainder. Well, what that means is you divided this out, it had a number, and then this remainder was 2/5. Well, that 2/5 can still be divided out. Okay, it was just that we were expressing this as a fraction remainder. And some of the ones that actually missed it on the test, that did it as a decimal, found that out. If we had a remainder of 2 here at the end, so let's just put some random numbers. Well, let's just put x's. I had this number, and then at the end I had 2, and I put that 2/5. But let's say I had done this as a division problem, and I was going to make it a decimal. Well, at that point, you put a 0, bring down the 0, and you have 0.4 because you did 5 into 2, which you made 20, it was 0.4. So 2/5 at the end of that, if I do 2 divided by 5 in a calculator, it's going to come out as 0.4. That's to show you that these values are the same thing. Whether you put 0.4 or you put 2/5 at the end, that is the same thing. Okay, and I know that's a little extra, but I want to show you that really a fraction is just a way to express something. Okay, so going back to a half, one that's a little more, kind of understandable is if we look at this as 1 divided by 2, that's all it is. It's a division. So, you know, when I get into 1/4, okay, 1/4, it's 1 divided by 4, which if you put that in your calculator, comes out to 0.25 or a quarter. 1/4 of a dollar is a quarter, 0.25. So that is, you know, what a fraction is. It's basically, to break this down into what they use it for, is if I talk about this is called the denominator. This is called a numerator. Okay, denominator is what's on bottom. That tells me the pieces that I've cut it into. So let's take this is one piece of paper, and let's cut it into 2 pieces. Okay, now in this case they have to be even pieces, meaning this piece, and I didn't quite do it right, but they have to be equal pieces. Okay, it's not just cutting it into one skinny slice and then this big slice. It's cutting it into 2 equal pieces. Same thing with a fourth. You know, it's cutting it into 4 equal pieces. So I've cut this paper into best as I could as 2 equal pieces. Having a half of that means you have one of those 2 pieces. I have half the paper now. I have one of the 2 pieces. If I had done this as fours, so I have these 4 pieces and they're equal. Okay, that means I cut the one paper. If I put them all back together again, I have one whole paper. But I've cut them into 4 equal pieces, and let's say I only have one of those 4 equal pieces, then I have 1/4. Okay. Now you can do that visually, meaning you could do it, you know, like with the paper there, or like if I took this cup, 1 cup, and those that bake know that some of you guys have done fraction stuff and you don't even think about what you're doing. But let's say I have a fourth of something, and I cut it into 4 equal pieces. So this is a fourth of a cup. I know you can't see the measurement, but it would take 4 of these to fill this cup. Okay, so there's a fourth of this. Same thing if I cut it into 3 equal pieces. Okay, it's going to take 3 of these to fill this 1 cup. Okay, so same thing with money. I have $1. I cut it into 4 equal pieces. So 4 quarters. And 1/4 would be one of those quarters. 1/4 of a dollar. So, you know, that's all it is, you know, that's all that a fraction is. What gets hard is when we get into adding them or, you know, changing the denominators. That's what gets students, you know, kind of like, oh, I hate fractions, because trying to remember the rules. And we'll try to, you know, I'm also, you know, the very next video is going to be a math annex on how to add some of them with different denominators, and then we'll cover that again. Basically, you know, that's where it gets kind of tricky. First thing I want to look at, though, that does math with these is reducing a fraction. And the videos from Friday kind of covered this a little bit, but I wanted to cover it. Let's say I have 50 hundredths, okay? And I want to reduce that. By reducing, I mean I want to make these numbers smaller, reduce them. Because I don't want to walk around and say, this is 50 hundredths of a cup, okay? This is a cup, okay? This is, let you know what this answer is going to be, is a half. I don't say this is 50 hundredths of this cup. Now, there is one place that, there's the reason why I use this one, that we still use this. If you still write checks, which I know some watching this video in my class have probably never wrote a check, and that just blows me away. I was in a Starbucks once and I was writing out my checks, and there was a girl that I thought was kind of my age, as far as she was old. I mean, she was close to my age, but I just thought, you know, I would thought she had the same experiences as me. She comes over and she's like, "What are you doing?" And I'm like, "I'm writing out my bills, writing out my checks." She's like, "What's a check?" Like, she's like, "You write checks still?" Like, she kind of knew what it was, but she's like, "You write checks? I pay everything online." It blew me away. I was like, for one, man, you know, I was like, am I really that old? But then two, I'm kind of like, yeah, I would rather write it out than, you know, have it online. But, you know, a check is something that we've wrote, most of us, And if you do that, let's say I write something for $7.50. Okay, you know you write that as $7 and oops, my hand looks like a cent. Okay, and then you write that 50 over 100 and you write it out. Now, the reason for that is if you break a dollar into pennies, our lowest currency to pay with, there's 100 of them. And if you have 50 cents, then you have 50 of that 100, okay? And so that's why you write it. And you're like, well, why didn't they go to where you reduce on a check? Because let's say it's 37 cents. Okay, so let's write a new check that's $8.37. So we write 8 and 37 over 100. That's easy to do because no matter what this is, you just put it over 100. They don't want people standing in line trying to reduce these down and trying to get that right. So let's say it's 36 cents. You got 36 over 100, and you're like, okay, that reduces down to, I can divide it both by 2, and I get 18 over 50, and I can divide that by 2. You know, they don't want people sitting doing that, so it's just easy, no matter what the change is, to write it over 100. 75 cents, 75 over 100. You know, 72 cents, 72 over 100. And so here's an example of, we write 50 over 100 to mean 50 cents. But we already know 50 cents is a half. This reduces down to a half. You don't walk around and say, I have 50 of a hundredths of a dollar. You say I have half a dollar. But when you write the check, this is 50 pennies over 100 pennies. So reducing is going to be, as we go forward, we're going to reduce these, unless we're writing a check, we're going to reduce these fractions because we don't want to say 50 over 100, okay? We want to get that in its smallest form. Now, how you do that is you find the biggest number that you can divide both these numbers by. It's called the greatest common factor, but we don't really have to get that deep into it for this class. We just need to know what's a number that I can divide evenly into both of these numbers, and I try to find the biggest. So in this case, 50, if I divide 50 by 50, I get 1, and if I divide 100 by 50, I get 2. It's the biggest number that goes into both of them. Now here's the thing, if you can't think of the biggest, you can at least work it down if you need to. Let's do another small one. Let's do 75 over 100, as far as, we can pretty well think. Now in this case, 50 will not go into 75 evenly, but the biggest number that goes into both of them is 25. 25 goes into here 3 times, but it goes into here 4 times. So once again, 75 cents is 3/4 of a dollar. Okay, 3/4. So 75 cents is 3/4 of a dollar. You have 3 of the 4. Okay, so that's that one reduced. 5/15. Okay, find the biggest number that goes into both of these evenly. Biggest number that goes into both is 5. 5 goes into here once, goes into here 3 times. This is 1/3. That's, you would not say this is 5/15. You would say this is 1/3. Okay, so this is reducing down. But what happens if you get one that is bigger? Okay, 26 over 36. Now here's a key. You do have to sometimes guesswork, like go through and think, is there a bigger number that goes into those? But if they're both even numbers, you at least know that 2 will go into them, okay? And so start with that. 2 will go into here 13 times, and then it goes into here 18 times. Now at that point, you can keep thinking, and you think, is there a number that goes into evenly into 13 and 18? And there's not, okay? There's, and the only number that will go into all of them is 1, but that doesn't reduce them down. If I divide them both by 1, I still get 13 over 18. So this is it. This is where I stop. That's as small as it goes. Let's do that with another one. Let's say we have 72 over 84. Okay, now here's a big number that we think, now there is a big number that goes into these that I can reduce it faster, but if, to learn it that quick, it would be hard. If you go through and say, okay, they're both even numbers, so I'm gonna at least divide them down by 2. So divide this by 2. You can use you can use your division. Like in this case, you can go over here and go through and say, okay, I almost said calculate, but this is a class without calculator. But you go over here and you can do your thing here, and you get 36, okay? And I'm okay even if you are trying to do these and you want to check yourself on a calculator, or if you want to, because really the key is to learn the fraction rules at this point. So even if you just kind of check your work with a calculator or a multiplication chart, I'm okay with that at this point. Just, I don't want you doing, using a scientific calculator and adding fractions into this. Okay, I want to see your work that you actually did it on paper to learn the process of it, and not just, when we get to adding fractions, not just plugging it in and letting the calculator tell you what the answer is. So I divided this by 2. I'm going to divide this by 2, and I get 42. Now at that point, I can see that they're still both even numbers, so I can divide them by 2 again. 36 divided by 2 is 18. 42 divided by 2 is 21. Okay. At that point, I can actually see that I can divide them again by 3. Now they're not both even, but I can divide them both by 3 because 3 goes into here. This is where you have to kind of guess. 6 times, and 3 goes into here 7 times. And now 6/7 does not reduce. There's nothing that goes into both those numbers. Now that was going by 2, then going by 2, and then going by 3. And that's okay if you do that. But if you already knew, hey, 12 goes both into these, 12 goes into here 6 times, and it goes into here 7 times, then you get to 6/7 faster. But you may not know that 12 goes into those. If you do enough math and you get used to those, or if you're good with your division, then you can maybe see that. But it's okay to step your way to it as long as you don't stop here. Keep checking to make sure there's not a number that goes into both of those numbers, okay? Best thing to do is, use your multiplication chart. Like, let's say you're here and you're trying to see if any number goes into there. Okay, let's say you got your multiplication chart and you look at your rows of 3s, and it's 3, 6, 9, 12, 15, 18. Oh, that's starting to look like one big number. So we'll put a space. Then it's got 3, and then 6, and then 9, and then 12, and then 15. And then 18, and then 21, and then 24, and so on. Well, let's say you look at that row and you see both of these numbers, 18 and then 21. Well, that tells you in your multiplication chart that 3 will go into both of those times. And then if you're wondering how many times, remember the multiplication chart is up here. It's, 1, 2, 3, 4, 5, 6, 7, 8. So when you look up here, you go, oh, it goes into 18 6 times, and it goes into 21 7 times. Okay? So that's what you can use to, as you're going through trying to learn. Now, the problem with that is some of these don't go big enough, and you may have to go down, like I said, and work your way down to, like the first part of that, you may not see it on your multiplication chart. You may have to work your way down to a smaller one like this, okay? So that's working through with reducing. Now, just remember, if you get down to an answer like 3/7, that does not reduce, okay? Or even, it could be a big number that doesn't reduce, 41 and 42. There is not a number that goes into 41 and 42 evenly. So that's where you stop, 41 over 42. So not all fractions reduce, okay? It's just kind of checking. And the more you get used to them, the more that you can do those quicker. The last thing on this that I want to introduce, so that's reducing fractions. You're going to have to do that on all your answers. So if I do a problem and I end up with 2/4, I need to reduce that down to 1/2. Okay, 2 divided by 2, 4 divided by 2. So you're going to be reducing your answers. The thing I want to look at is adding and subtracting fractions, but we're gonna stop today at they have to have the same bottom. Okay. So let's say I do 1/2 plus 1/2. meaning they have the same denominators. And tomorrow we'll work, and unfortunately my night class will have to watch tomorrow's video too. But this is going to be just stopping at, the denominators are the same. How can you add that? Now, I can't just add the tops, 1 plus 1 is 2, and add the bottoms, 2/4. Because, what did we just say? What is 2/4 reduced down? 2/4 reduced down is 1/2. Okay, well, you can't take a half, add in another half, and end up back where you started, at a half. Okay, so it's not just adding the tops and adding the bottoms. Okay, a half plus a half is not a half. You have to add them together. A half plus a half should be 1. Okay, it should be a whole 1. Like if I take a half cup, pour in another half cup, I have a full cup. Well, that means that if I just add the tops, but always keep the bottoms the same, then that means that you have 2 over 2, which 2 divided by 2 is 1. This reduces down to 1. If you end up with a number over another, like 17 over 17, that's going to always be 1. Okay, if it's over itself, anything divided by itself is 1. That's what it reduces down to. So a half plus a half is 1. Okay, so that is the process for that. Let's do it with a third and a third. Okay, let's take a third of a cup and add in another third of a cup. Well, everybody that bakes knows that's 2/3. Well, that means you kept the bottoms the same, which is what you're going to do with a fraction when you're adding fractions. Keep the bottoms the same, and you just add the tops. Okay, 2/3. It's the same with subtraction. Okay, if I take 3/4, and let's do it like this. Let me use the money example. And let's take away a fourth. Okay, so let's say I have 3/4 of a dollar. I have 3 quarters here. Okay, I have 3/4, and I take 1/4 away. 1/4 is a quarter. I should be left with 50 cents, or in the case of a fraction, a half. I should be left with a half a dollar. I have 2 quarters. So let's check and make sure we have that. 3/4 minus a fourth, so we keep the bottoms the same. Whether you're adding or subtracting, the bottom stays the same. 3 minus 1 is 2, and what is 2/4 reduced down to? A half. So if you have 3 quarters minus 1/4, you end up with 50 cents or a half a dollar. Okay, so as far as just adding and subtracting, that's why we're going to stop there, because that's our first rule. Is really, it's easy. You just keep the bottom the same, and then add or subtract the top. Okay, well, if it's an addition problem, add the tops. If it's a subtraction problem, then subtract the tops. Okay, let me put 4 problems up real quick. Actually, I think I got 6 problems. Sorry. And then have you do these and upload this for your assignment. So 2/7 plus 3/7, and 1/6 plus 2/6, and 4/3. 4/9 minus 3/9, and 7/8 minus 5/8, and 60 over 80 minus 20 over 80, and 36 over 48 plus 10 over 48. And just no matter how big the problems get, the bottom stays the same. So keep that in mind. Now what I want you to do on all of these answers is reduce them. And show your work so that I know maybe, start out with what you get for your answer and then show your reducing. That way I know if you messed up at the first part of this or if you got that right and just reduced wrong. Okay, so show your work on that, and then we'll check that for today's assignment. Okay, thanks guys.